Welcome back to the deep dive. Today we're going to do something a little bit different.
Oh, yeah.
Yeah, usually we're looking out at the world, at markets, at history, these big geopolitical trends. But today I want to look at something that is, well, it's probably in your pocket right now
Or on your desk.
or on your desk. It might even be the thing that decided to serve you this very audio file. We are talking about artificial intelligence.
It is the topic of the decade, isn't it?
It really is. And I feel like everywhere you turn, the conversation is just so breathless.
Mm-hmm.
It's either AI is going to save humanity, cure cancer, or it's the robots are coming, they're going to take our jobs.
And turn us all into paperclips.
And turn us into paper clips.
Yeah.
It's very binary, it's very loud, and honestly, a little overwhelming.
It is loud. And a lot of it, frankly, is just noise. It's marketing fluff.
That is exactly why I wanted to do this. We've pulled together a whole stack of sources to answer a much stickier and I think a much more interesting question than just, is it good or bad? We're asking, is artificial intelligence actually intelligent?
That is the million-dollar question.
Or trillion-dollar, maybe.
Maybe the trillion-dollar question, given the market caps we're seeing. Because, the marketing would have you believe that we've created a digital mind, a silicon brain that thinks and reasons and understands the world just like we do.
But a million times faster.
Only a million times faster.
Right. We see these chatbots, and they seem so human. They can make jokes. They can apologize.
He can write poetry. It feels like there's a who in there.
Exactly, a who.
But the whole premise we're going to explore today is that when you actually peel back the layers, when you look at the raw mechanics, you find something very different.
You don't find a mind.
You find a machine.
A machine that's really, really good at one specific thing.
It's a prediction machine.
Okay, prediction machine.
Yeah.
Let's unpack that right from the start, because prediction machine sounds a lot less sexy than, artificial general intelligence.
It does, but it's the core of it all.
So the idea is that these systems don't think like us. They're fundamentally about statistics, not understanding.
Precisely. And our mission for this deep dive is to really explore that distinction. We want to get into why AI is an absolute genius at the boring stuff. Repetitive tasks, scanning documents, but why it completely falls apart the moment life gets unpredictable.
Like with the pandemic, we're going to get to that.
We are. We're going to look at why that event caused some of the world's most sophisticated AI models to just essentially crash.
And here's where it gets really interesting for you listening. We're going to flip the script a bit on human intelligence, too.
Yeah.
We're going to talk about why your gut feeling, that thing you might just dismiss as vibes or whatever, is actually a high-level data processing skill that machines just can't replicate.
It's about distinguishing between math and mind. So, yeah, let's dive in.
Let's do it. So, segment 1, the prediction machine. You said AI doesn't know truth, it knows probability.
Yeah.
That sounds kind of semantic, but I feel like it's a huge distinction.
It's everything. At its absolute core, all this new generative AI, the large language models. It's best to think of them as a massive drop in the cost of prediction.
Okay, but when you say prediction, I'm thinking about the weather next week or, who's going to win the Super Bowl.
Right, looking forward. And that is one type. But in this context, prediction is a bit broader. It means using data you have to generate data you don't have.
Filling in the blanks.
Exactly. It's about filling in the blanks.
Okay, give me an analogy. Make it concrete.
Okay. Imagine I hand you a photograph, but I've cut a square hole right in the middle. You can't see what's in that square. That's the data you don't have.
Okay, so I've got a picture with a hole in it.
Right. But you can see the rest of it, the context. Let's say to the left of the hole, you see a long furry tail. To the right, you see some whiskers.
I see where this is going.
At the bottom, 4 paws. What do you predict is in the middle?
I'm going to go out on a limb here and say a cat.
You predict cat.
Yeah.
Now, how did you do that? Did you, do a DNA test on the pixels?
No, of course not. I've seen a lot of cats. I know the pattern. Tail, whiskers, paws, cat.
Exactly. You have a training set in your brain. You've seen thousands of cats. You know that when those pixels are arranged in that specific geometry, the missing piece is almost always a cat.
So AI does the same thing, just with math.
That's all it is. It looks at millions of images of cats, which are just numbers to the computer.
Yeah.
And it learns that when pixel pattern A is next to pixel pattern B, the missing bit is usually pixel pattern C.
It doesn't know it's a cat. It doesn't know that it purrs or scratches the furniture.
No, it has zero concept of catness. It just knows that this pattern of numbers usually goes here, It's a statistical correlation engine.
So when I type a prompt into a chatbot, write me a poem about a sunrise, it's doing the same thing.
The exact same mechanism. It takes the data you gave it,
Hmm.
your prompt, and it looks at its training data, which is basically the entire internet. And it asks, given these words, what is the most statistically likely next word?
That.
Probably the. Then looks at the and predicts the next one. Sun, then rose.
It's not feeling inspired by the sunrise.
It's calculating the most probable sequence of words to satisfy the pattern you gave it.
So it's like a really, really, really expensive and powerful autocorrect.
That is a fantastic way to put it. It's autocomplete on steroids.
Yeah.
But, and this is a huge but, this leads to what we call the rearview mirror problem.
The rear view mirror.
Since it's learning exclusively from data it's already been fed.
From the past. It's training data.
Right. Its entire universe is the past. It only knows what has already happened.
Which means it has to assume the future will look pretty much like the past.
100%. It cannot imagine a future that isn't in its data. It can only rearrange pieces of the past to predict what's next. So if the world changes in some fundamental way,
The AI is still playing by the old rules.
it's driving down the highway at 100 miles an hour, but the windshield is painted black. It's only looking in the rearview mirror to steer.
That's a great metaphor. And on a perfectly straight road, that probably works okay.
It works great. You can go really fast, faster than a human.
But if the road curves...
You fly off a cliff, and we are absolutely going to talk about that crash. But first,
Right.
let's give the devil its due. Let's talk about where this actually works.
Right, we don't want to just sound like we're trashing the tech. I mean, I use it every day. It's incredibly useful.
In business, it's a total game changer. This is the sweet spot, the repetitive, and the rule-based. Because what's the one thing humans are just terrible at?
Boredom. Repetition. I can't stare at a spreadsheet for 8 hours straight without my eyes glazing over. I start thinking about what's for lunch.
Exactly. We're biological. We get tired, we get distracted. And AI never gets tired. It never gets bored. It can process a volume of data that no human could match in 1,000 years. Think about logistics.
Okay, let's talk about yogurt, the example from the sources. Seems mundane, but it's a huge deal.
It is mundane, but it's incredibly complex. If you're a giant retailer, you need to decide how many cartons of strawberry Greek yogurt to ship to store #451 in Ohio for next Tuesday.
Send too many, they expire, you lose money. Send too few, the shelf is empty, and the customer's annoyed.
Right. It's a constant balancing act.
Yeah.
Now, a human manager, they can look at last year's sales, make a good guess. But an AI can look at the sales data for every single day for the last decade.
And it can see other patterns.
It can factor in the weather forecast. Maybe people buy less yogurt when it's cold. It can factor in local events, a new health trend, the fact that everyone goes on a diet in January.
It's spotting the patterns that are too subtle or just too big for us to see.
Right. And it does it for millions of products at once. And it works because, yogurt buying habits are pretty stable. The pattern holds.
Or recommendation engines. Netflix, Stitch Fix. This is probably where most of us bump into this stuff every day.
People who bought X also bought Y. That's the whole game. Again, it's just pattern matching.
It doesn't know why I like that gritty Nordic crime drama. It doesn't get that I appreciate the cinematography.
Nope. It has no concept of plot or mood. It just knows that, 80% of the other people who watched the show you just finished also watched this other show.
So it puts me in a little cluster of users who behave like me.
And it serves you what the rest of the cluster liked. And it works incredibly well.
Keeps us watching.
And then there's fraud alerts. This is a really high-stakes one.
Yeah, that horrible moment when your card gets declined trying to buy dinner on vacation.
That's classic anomaly detection. The credit card companies scan millions of transactions a second. They build a pattern of what's normal for you. You buy coffee in New York at 8 a.m. You buy groceries on Sunday.
And then suddenly my card is used to buy an expensive watch in London.
And you just bought a bagel in New York an hour ago.
Right.
That breaks the pattern. The AI flags it. The probability of you moving at supersonic speeds is basically zero. So it freezes the card.
This all brings us to something I found really counterintuitive in the research. We tend to think AI is smart because it can do things that are really hard for humans, like, advanced math or playing chess at a grandmaster level.
Right. We see that and we think, wow, genius.
But there's this idea called Moravec's paradox that just completely flips that on its head.
Yes. Moravec's paradox is so fascinating. It comes from Hans Moravec, a robotics researcher back in the 80s. He noticed this thing that drove him and his colleagues crazy.
What was that?
It was relatively easy to make computers do what we consider Hard intelligence, logical reasoning, algebra, chess,
The smart stuff.
the stuff we study for.
Yeah.
But it was almost impossibly difficult to give them the skills of a one-year-old child.
A 1 year, like what?
Folding a piece of laundry, walking across a messy room without
Yeah.
tripping over a toy, recognizing your mom's face in a crowded room instantly.
Picking up a fragile egg without smashing it.
Exactly.
Why is something like advanced calculus easier for a machine than just folding a towel?
It all comes down to evolution. Think about it. Abstract thought, math, logic, language, that's a really new trick for our brains, maybe 100,000 years old.
It's like the latest software update.
It's the thinnest veneer on top of everything else. But perception, motor skills, just moving through the physical world, we have a billion years of evolution baking that into our hardware. We are, all of us, Olympic-level athletes at perception and movement.
We just don't realize it because it feels so easy. We don't have to think to walk.
No, but walking is this massive computational problem. You're sensing the terrain, adjusting your balance in milliseconds, coordinating hundreds of muscles. But because it's unconscious, we think it's simple.
So for a computer, logic is easy because it's just rules, but the messy physical world is incredibly hard.
That's the paradox. We're impressed by the calculator, but we should be blown away by the toddler navigating the living room.
That toddler is performing a feat of sensory processing that our best robots still struggle with.
You really do.
Okay, so AI is a prediction machine. It loves patterns, it loves rules, it loves the straight, boring highway. But what happens when the pattern breaks? What happens when the world does something that isn't in the training data?
This is where we get to the crash. And we have a perfect real-world case study for this. It's from a thesis about a huge global manufacturing company. Let's just call them Tyreco.
Tyreco. Big, sophisticated company.
Extremely sophisticated. They were the poster child for using this stuff. Advanced statistical models to predict tire demand all over the world, and for years, it worked like a charm.
Because tire sales are pretty predictable.
Very. It's seasonal. Snow tires in the winter, performance tires in the summer. People drive more on vacation. The past reliably predicts the future.
And then 2020.
And then 2020, the Black Swan event, COVID-19.
A black swan being an event that it's super rare, has a huge impact, and crucially, you couldn't have predicted it from past data.
Exactly. There was nothing in the tire sales data from 1990 to 2019 that said global pandemic lockdown.
So March 2020 hits, the world shuts down, nobody is driving. I remember seeing pictures of totally empty highways.
Demand for tires just fell off a cliff. It dropped over 60%, basically overnight.
So what did the AI models do?
They panicked. I mean, mathematically panicked. The error rates in their forecasting models didn't just go up a little bit, they spiked by 500%.
500%. That's not an error, that's a hallucination.
It is. Because the models were staring into that rearview mirror. They saw this sudden drop in sales, and they tried desperately to fit it into a historical pattern.
It's like they were asking, have I seen this before?
Right. Maybe it's a weird seasonal dip, a really, really bad recession. They kept predicting, based on the old world's rules, because they could not comprehend that the world itself had fundamentally changed.
It didn't know what a lockdown was.
The word didn't exist in its data set in that context. And this led to something that researchers call the bifurcation of error.
Bifurcation of error. Okay, break that down for me.
It means the automated system started making these wild, contradictory predictions. The data was so far outside the norm, the algorithms just became unstable. Some models predicted massive shortages.
Shortages when no one was buying.
Yeah, they were telling the factories to churn out tires like crazy because their math said, this dip is an anomaly. Sales must bounce back immediately.
While other models were predicting the opposite.
Exactly. Other models saw the drop and predicted a massive overstock, telling everyone to shut down production. So the poor supply chain planners were getting automated alerts to speed up and stop at the exact same time.
The whole system just ground to a halt.
It broke. The math broke because the fundamental assumption that tomorrow is basically correlated with yesterday was no longer true.
The AI sees the numbers drop, but it has no context. It doesn't read the news.
It has no semantic understanding. It sees a data point. Sales down 60%. It does not see the reality. People are scared and staying home to avoid a deadly virus.
And without that meaning, the prediction is worse than useless.
It's dangerous. It could have bankrupted them if humans hadn't stepped in.
And that is the perfect segue to the human advantage, because Tyreco did not go bankrupt.
Humans stepped in. They pulled the plug on the autopilot. And this highlights the critical difference between processing data and adapting to change.
Humans adapt to unfamiliar situations way faster than the machines.
Way faster.
Why? If the machine is faster at processing, why are we faster at adapting?
It's because of a capability that researchers call not knowing.
Not knowing. That sounds like a weakness, like I'm unprepared.
It sounds like it, doesn't it? But it's actually a profound strength. Humans can function. We can make decisions even when we don't have all the data. We're comfortable with ambiguity and the unknown.
Whereas an AI needs data. If the data isn't there or if it's weird.
It crashes. A human looks at the unknown and says, okay, I don't know exactly what's happening, but I can read the room, I can sense the context, and I can make a judgment call.
This connects to that Greek concept you mentioned, phronesis.
Yes, phronesis.
Yeah.
It's an ancient term from Aristotle. It's usually translated as practical wisdom.
So not just book smarts.
Exactly. Aristotle made a distinction. There's episteme, which is scientific knowledge, like knowing facts, and there's techne, which is craft, like knowing how to build a table. Phronesis is different. It's judgment. It's the ability to do the right thing in a specific, messy, real-world situation.
And the sources had a great example of this, the ER nurse.
It's a perfect example. Imagine an experienced ER nurse. They walk into a patient's room, all the monitoring equipment, the AI basically shows the patient's vitals are stable. Heart rate is fine, temperature is fine.
The screen is green. The data says everything's okay.
But the nurse walks in and instantly knows something is terribly wrong.
How?
Sensory perception, embodied judgment. The nurse sees the patient as a specific shade of pale, a gray color they've seen before in critical patients. They hear a tiny, subtle catch in the patient's breathing. They can just feel the tension in the room.
That's the gut feeling.
Right, but that gut feeling isn't magic. It's high-level data processing. It's a result of seeing thousands of patients over a 20-year career. It is lived experience turned into instinct.
The nurse is synthesizing all this sensory and emotional data that the machine can't even perceive.
Exactly. The machine can record the temperature down to a decimal point, but it can't feel the situation. It doesn't know what pain feels like. It has no body.
So emotions, sensory perceptions, they're actually carriers of information.
They tell us what's important in a situation. An AI sees 1,000,000 data points as equal. The nurse sees the room and knows that shade of gray on his skin, that's the data point that matters right now.
So the AI sees correlation, but the human understands the story. We understand the why.
And the why is everything, which brings us to the difference between correlation and causation.
The classic trap. Correlation does not equal causation.
It's the oldest rule in statistics. Just because the rooster crows when the sun rises doesn't mean the rooster caused the sunrise.
And AIs fall for this all the time.
Constantly. By their very nature. They are correlation engines. They find patterns. They don't understand the causal mechanism behind them.
Okay, let's use that credit card example again.
Right. So you're on a road trip. You stop for gas in, I don't know, rural Arizona. You swipe your card. The AI at the credit card company rejects the transaction.
And it's so frustrating. You're just trying to get back on the road.
From the AI's perspective, it's just math. It sees a pattern. Card used in location X, customer lives in location Y. The pattern doesn't match. Therefore, high probability of fraud.
But it's missing the why.
It have no idea you decided to take a spontaneous road trip to see the Grand Canyon. It has no concept of vacation or adventure. It only knows the numbers in the pattern.
And this is where the human judgment part comes in, because there's a trade-off.
A huge one. And it's a business decision, not a math problem. The company has to decide what's worse. Is it worse to stop a perfectly valid transaction which embarrasses you and makes you angry at their company?
Or is it worse to accidentally let through a $50 fraudulent charge?
That's a value judgment. And an AI can't make a value judgment. The AI provides the prediction, 85% chance this is fraud. But a human has to decide on the payoff.
What do we care about more? Perfect security or a good customer experience?
Exactly. It reminds me of that phrase, data rich but insight poor.
We're drowning in data. We have all the spreadsheets in the world. But data just tells you what happened.
It's the oil. It's not the refined gasoline. Insight is understanding what it means. And you need a human for that. You need the why.
Okay, so this brings us to a really serious point. If AI is just a math-based prediction engine and it lacks this phronesis, this practical wisdom, who is responsible when it messes up?
This is the responsibility gap.
Yeah.
And it's a huge legal and ethical issue right now.
If a self-driving car crashes or a medical AI misdiagnoses someone, who's to blame? The programmer. The user.
To blame the algorithm, you can't put an algorithm in jail.
Right.
But the even bigger danger is something called the active responsibility gap.
What's that?
It's the risk that we humans just stop feeling responsible for outcomes because, the computer said so.
Computer says no. The ultimate excuse to not think.
It is. A loan officer used to have to tell you why you were denied. Your debt-to-income ratio is too high. Now they might just say, look, the system gave you a score of 400. It rejected it. My hands are tied.
So they abdicate their own judgment to the machine.
And if that machine is biased, which we know they can be because they're trained on our own flawed historical data, then we're just automating our past mistakes and washing our hands of it.
Which is why this idea of meaningful human control is so important.
We have to keep a human in the loop. We have to see AI as a tool for augmentation, not total automation of high-stakes decisions.
So the human isn't just there to rubber stamp what the AI says.
No, that's incredibly dangerous. Meaningful control means the human understands why the AI is making a suggestion and then uses their own phronesis, their own judgment, to make the final call.
Like the doctor with the X-ray.
Perfect example. The AI is brilliant at scanning the image and spotting a tiny shadow a human eye might miss. That's pattern recognition.
So the AI says, hey, doctor, you should look at this spot.
Exactly. But the doctor makes the final call. They consider the patient's history, their fear, their family, their values. The doctor provides the meaning.
Humans plus AI is better than AI alone.
That's the synthesis.
Yeah.
But AI alone, in these complex, messy human situations, is a recipe for disaster.
It really all comes back to that idea of the intern, doesn't it?
The super smart intern.
So as we wrap this up, if you're a leader or just anyone trying to figure out this AI world, that's the mental model to use.
Think of AI as the smartest intern you've ever hired. This intern has read every book ever written. They can calculate pi to a million places in a second. But
they have zero life experience.
Zero. They've never had their heart broken, never negotiated a tense deal, never raised a child, never lived through a pandemic.
No.
They have all the book smarts in the world, but no street smarts.
They have processing speed, not wisdom.
Precisely. So would you let that intern make the final call in your company's entire strategy?
Absolutely not.
You'd use them to do the heavy lifting, to gather the data, to present the options. But you make the decision. You provide the judgment. You provide the phronesis.
Because you're the one who understands the context and who's ultimately accountable.
You can't outsource your responsibility to a probability curve.
That feels like a powerful place to land. It's the more advanced the tech gets, the more valuable our human skills become. Empathy, judgment, adapting to the unknown.
Those aren't becoming obsolete. They're becoming the premium features. In a world where everyone has the same AI, the difference maker will be the quality of the human judgment guiding it.
So next time you see a headline about AI taking over, just remember the toddler walking across the room.
Remember the ER nurse. Remember that prediction isn't understanding.
And keep your hands on the wheel.
Even if the car has autopilot.
I love that. Well, this has been a fascinating look at the limits of the machine and the power of the mind.
Always a pleasure to unpack the reality behind the hype.
And a final thought for you listening. If AI is the engine, where are you steering the ship? Because the engine doesn't care where it goes. That part is up to you. This deep dive was brought to you by Tech9 Labs, promoting the responsible use of technology. Thanks for listening, and stay curious.
Goodbye.